Good morning, everyone. This is Suzanne at the State Library. I am the supervisor for the Indiana State Library's Professional Development Office. Thank you guys so much for joining us for today's webinar. We are pleased, so pleased to have Greg McCauley here from the LINC. He is the executive director of the LINC Observatory Space Science Institute, and he is just a charming person. And I can't wait for you guys to all hear all the great things he's going to share with you today. I want to start off the webinar with a few announcements. This webinar is provided as part of the Library Trends and Hot Topics series today. To register for other webinars available for this series or other trainings available from the Professional Development Office, please see the Indiana State Library's events calendar, which can be found on our website at library.in.gov under Services for Libraries. And for a full list of our current in-person training menu, please see our continuing education website. The Indiana State Library has many ways that we try to stay connected to library staff around the state. For weekly updates on upcoming trainings and to learn more, please go ahead and subscribe to our weekly e-newsletter, which is the Wednesday Word. We also offer a blog, which provides information about our collection, interview spotlights on library staff from around the state, and information about upcoming events at the State Library. If you have any sound issues during the webinar, please see the sound issues box that's just below the chat box. If there's any global sound issues, we will announce it in the chat box. If you are unable to resolve the sound issue that you're experiencing, please know that we are recording the webinar. You can watch it offline after the meeting has ended. So again, if there's any global sound issues, we will make an announcement in the chat box, and at this time, we are not experiencing any global sound issues. So the other thing I wanted to mention is your LEU will be available for download at the end of the webinar, so we'll have that document available for you to grab at the end. And I'll also have a survey for you at the very end that you guys can take. So without further ado, I'm going to turn the presentation over to Greg. We're going to turn the sound off for just a second while we get acclimated, and then we'll get going.
Hello, everyone. This is Greg McCauley with the LINC Observatory Space Science Institute, and we have been looking forward to this all week to be able to speak with all of you. Thanks for attending. I wanted to start off talking about the observatory just a bit, and we're going to get into one of the greatest astronomical events of this century, which is the Great American Eclipse, and we're going to explain all the details and how you can provide information and training and a lot of fun stuff for the public at your libraries. Again, LINC Observatory Space Science Institute, we share the wonders of the universe in ways that inspire, educate, excite, challenge, and educate. And a little bit about me. I'm the executive director and CEO of the LINC Observatory Space Science Institute. I'm also what's called a NASA JPL Solar System Ambassador. And the JPL is the Jet Propulsion Lab out of Pasadena, California. That's where all of the planetary exploration takes place and is managed. I'm a member of the Indiana Astronomical Society. At one time, I was on the board of directors for 3 years. And I'm a former NASA employee. I was with the Apollo program in mission planning and analysis at the Manned Spacecraft Center in Houston, Texas, which is now the Johnson Space Center. And this was in the early 1970s, in 71 and 72. I was there for Apollo 15 and Apollo 16 and was on the lunar launch team for Apollo 17 in Mission Control Building 30 and held a top secret NASA clearance at the time. So I have been a lover of space stuff all of my life, and I'm pleased to be here and excited to share what this program has to offer. Our mission is to advance scholastic literacy of future generations with informal STEM education focused on NASA missions, astronomy, and space exploration, and to foster scientific curiosity and advance science literacy to cultivate and nurture the next generation of leaders. We are involved in STEM education, STEM science, and public engagement. And with our public engagement programs, I'll kind of start there at the end. We are involved with a wide variety of libraries around central Indiana and have had so much fun and so much success bringing NASA missions and astronomical events to the general public, to sellout crowds or to standing room only crowds all throughout central Indiana. And we're available throughout the state of Indiana as well if you'd like to make contact with us and have us come to your library with one of our Link Live programs. We can explain what that is later on if you'd like to make contact. Just go to linkobservatory.org, L-I-N-K, observatory.org, and then go to the contact page and fill out some information that comes directly through the system to me, and I can respond. STEM education and STEM science, you all know what that is. We have over 20,000 students in central Indiana on our programs with NASA missions primarily. We bring NASA into the classroom. We are a partner with the NASA Digital Learning Network. That's out of Langley Research Center, NASA's Langley Research. We're also we have programs and are partners with NASA Kennedy, NASA Johnson, NASA Jet Propulsion Lab, and the Goddard Space Flight Center. Much of the animations and the imagery you're going to see today comes from Goddard Space Flight Center. They're the ones that manage the SDO, which is the Solar Dynamics Observatory, and a lot of these images came from there. We're also involved very heavily with Indiana University. They own the Link Observatory and have since 1948. Purdue University partnership, Ball State University, University of Indianapolis, and then we have partnerships with the Indianapolis Children's Museum, the Indiana State Fairgrounds, and Conner Prairie, and provide a variety of public events and educational events with them as well. So today, we're going to talk about the Great American Eclipse, and the subtitle is Standing in the Shadow of the Moon. The Great American Eclipse is that very thing because, and I'm going to give you some statistics here in a minute, it's the United States or North America is the only continent that's involved in this eclipse, and so it becomes our eclipse. This is the Great American Eclipse. And during that eclipse, which happens August the 21st, upcoming, in just a few months, you will literally be standing in the shadow of the moon. And what we say here is a mighty darkness is about to descend upon the land, and that's exactly right. Let's talk a little bit about the sun. We'll find out some amazing facts about the sun. The sun alone contains 99.8% of the total mass in our solar system. That's all of the planets. I don't know whether you knew this or not, but we have over 215 moons in our solar system. That's all 8 planets, including Pluto, the dwarf planet, and all of the items in the asteroid belt and the Kuiper belt, everything all put together. The sun still holds 99.8% of all the mass of the solar system. The temperatures inside the sun can reach 15 million degrees Celsius, and over 1 million Earths could fit inside the sun, just to give you an idea of the sheer volume of this. If you look at that picture right there of the sun, if we drilled a hole down the center of it, dropped Earths in there, we could drop 1 million of them in. So it's a giant thing. It's 870,000 miles in diameter. And if you look to the right in that image, these represent the Earth, Neptune, Uranus, Saturn, and Jupiter, as far as their relationship to the size of the sun. Again, it's 870,000 miles in diameter, and the sun is traveling through space at 490,000 miles per hour. The sun is one of billions of stars in the Milky Way galaxy, and we're kind of in the outskirts on one of the spiral arms of the galaxy. And as the galaxy spins and rotates in space, everything in space is moving. Everything in space is orbiting around something else, which in turn is orbiting around something else, which in turn is orbiting around something else. It really is a unique dynamic of the universe, but nothing stays still. And so we're traveling around the core of the Milky Way at 490,000 miles an hour. Now, here's some amazing facts about the sun. I really found this interesting. The sun's energy is generated in the core by a process called hydrogen fusion. And the temperatures and the pressures inside of the core of the sun are so extreme that the fusion process can take place. And hydrogen atoms can fuse into helium, deuterium. It's kind of a complicated issue. But the byproducts of that fusion are heat, radiation, and light. So photons of light are created at the core of the sun. A lot of people believe that the light comes from the outside of the sun, the surface of the sun. It doesn't. It starts in the core. And these photons, as they are generated, of course, photons have mass. They're affected by gravity. These photons collide with atoms of hydrogen inside the sun, and they bounce around through a thing called Brownian motion. Dr. John Brown was a physicist who had theorized these calculations to be able to determine this random movement of particles as they collide with each other in a gas or a liquid. Therefore, it's called the Brownian motion. Look at this animation. These are photons of light bouncing off atoms of hydrogen in the sun, and they can bounce around for 170,000 years at the speed of light inside the sun before they finally migrate to the outer surface and escape the sun. Still going the speed of light, it takes 8 minutes and 20 seconds for those photons to reach Earth at 93 million miles away. So when you, after this webinar, if you go outside and the sun shines on your face, those photons were created 170,000 years ago. But once they escaped the sun, it only took 8 minutes and 20 seconds to get to your face. So this is really interesting facts about the sun that you can share with your patrons. Now, here's some interesting things as well. I gave some specific numbers to the diameter of the sun, 864,575 miles in diameter. It is about 93 million miles away from the Earth. That's an accurate number down there, 92,956,807 miles. That's on the average. The Earth is not a circular orbit around the sun. It's elliptical. There are no circular orbits. And so it's a mild ellipse. It's about 7 or 8% elliptical. But the average distance between the sun and the Earth is about 93 million miles. But take a look at this. The moon is 2,159 miles in diameter. It's 238,855 miles on the average away from the Earth. It too has an elliptical orbit around the Earth, about 6%. But here's the interesting thing about that ratio. The sun is 400 times larger and 400 times further away than the moon. And so, because of this equal size to distance ratio, the sun and the moon are the same apparent diameter in the sky, about 1/2 of a degree of arc angle. It's the only time this happens in our solar system where a moon and the sun are the same diameter, and it's only because of their relative size and distance from planet Earth. So this is what a solar eclipse looks like, and I'm sure you understand this. This is when the moon comes between the sun and the Earth. And this diagram shows the sun with the Earth right in the path of the sun to the Earth, and this dark shadow in the center, which is where the total eclipse occurs. That's called the umbra. Now, around that dark shadow is a lighter shadow, and that's called the penumbra. In that lighter shadow is where the partial eclipse can be viewed from the surface of the Earth. You can see the Earth's orbit delineated there, and the moon's orbit around the Earth. Now, as you all know, I'm sure, the moon orbits around the Earth once every 28 days. Once every 28 days. Here's a great question, and I'm sure you'll have people ask you this. Why is it that we don't have a solar eclipse once every 28 days? And then when the moon is on the opposite side of the Earth, we have what's called a total lunar eclipse. Why don't we have one of those once every 28 days if everything is arranged like this? Well, here's the answer. The moon's orbital plane is 5 degrees 9 minutes inclined from the plane of the ecliptic. The plane of the ecliptic is that straight line between the Earth and the sun. The moon's orbit is inclined from that, so it doesn't always pass between the Earth and the sun. If the orbital planes were the same, then we would have a solar and a lunar eclipse each month, but we don't because of this. Take a look at this. If you look in the upper left-hand corner where it says no eclipse, the moon orbits the Earth below the plane of the ecliptic. And so the shadow of the moon never casts itself on the surface of the Earth. If you'll look just opposite of that, down around the 5 o'clock position of this diagram, there's no eclipse in that position either, and that's half a year later, because that blue dashed line is the Earth's orbit around the sun, because the moon is traveling above the plane of the ecliptic, and the shadow of the moon never touches the surface of the Earth. It might at the poles, but we'll never have a total solar eclipse. If you go over to the 2 o'clock position, you'll see that the moon crosses the ecliptic because of its angle to the sun. And when the moon crosses the ecliptic, which you'll see there at the 2 o'clock position, and again down at the 7 o'clock position or 8 o'clock position, that's when solar eclipses or total solar eclipses occur. Now, you might think that eclipses are rare. They really aren't. From a global perspective, solar eclipses happen pretty frequently. During the 21st century, through that 100-year period, there'll be 224 solar eclipses worldwide. This diagram shows 50 years of solar eclipses. Total and hybrid solars, we'll talk a bit about that, from 2010 to 2060, this is a 50-year period. Take a look at the paths of totality across the face of the Earth and the dates that those will happen. Look on the left, you'll see in Central Africa, just below the equator, that happens in 2041. And since orbital mechanics are so exact, we can predict these things long into the future. In this diagram, we're going to talk about the beginnings of 3 types of solar eclipses: a partial eclipse, an annular eclipse, and a total eclipse. Let's start with a partial eclipse. A partial eclipse is when the moon never fully covers the disk of the sun. If you'll take a look at this diagram, you'll see a line that runs from the upper west coast of America, the Portland, Oregon area, across the U.S., from the left to the right, from the west to the east, and then exits off the United States at South Carolina. That's the path of the umbra, or the path of the total eclipse for the upcoming August 21st total eclipse. That orange circle around is the path of the penumbra, or the partial eclipse. And the further you go north from that line of totality, or the umbra, or the further you head south, the less of the sun is actually being covered. And so the partial eclipse that looks like this, that partial eclipse is because, in this particular case, you're north of that path of totality, and the sun is peeking over the top of the moon. If you can understand that. If you were south of that path of totality, it would be just the opposite, and you would see the sun at the bottom of the moon. And the further south you would go, the more of the sun you would see, simply because your angle of view has changed across the surface of the Earth. Now, let's take a look at an annular eclipse. Don't know if you've ever heard of that, but what creates an annular eclipse is this. We're looking down from space onto the north pole of the Earth, and this is the elliptical orbit of the moon around planet Earth. This non-circular orbit causes variations in the moon's apparent size. We're going to stop that when we get over to the 9 o'clock position, just right here. And this is when the moon is the furthest distance from the Earth. The moon at that point will appear just a bit smaller in the night sky because it's further away. It's simple to understand. If you were over in the 3 o'clock position or closest to the Earth, that's what's called a supermoon, and you've probably heard of those. That's when the moon is the closest to the Earth and its apparent size is larger. It's easy to understand. Well, when we have an eclipse, when the moon is furthest away from the Earth and its apparent size is the smallest, that eclipse looks like this. The disk of the moon doesn't fully cover the disk of the sun because it's a bit smaller in apparent size, and we have this bright ring or an annular eclipse. And that's when you hear that term, that's exactly what it's going to look like. It's a really odd sensation to see the center of the sun being eaten away, which the ancients used to think it was a bad thing. That's what an annular eclipse is. Now let's talk about the total eclipse. A total eclipse looks like this. It obviously occurs when the sun and the moon are the same apparent diameter and the moon completely covers the sun. What you see around the perimeter is the sun's corona. And this is the only time humans can see the sun's corona, is when the bright disk is covered by the moon. If you look at about the 11 o'clock position of that diagram, you'll see this little orange thing coming up. That's called a prominence, and that's a solar flare. And you can actually see those during a total eclipse. I wouldn't recommend it because it's dangerous to look at the sun. Not so much when the moon is fully covering the disk, but when it starts to move away, it can be dangerous to the retina. And we'll talk about that later on in the webinar. Let's animate this, and we're going to move the moon across the surface of the sun in a total eclipse. Here we go. It's going to move across in an apparent arcing motion. The eclipse is going to travel from the west to the east, and now it's going to completely cover the sun, and there's that beautiful corona. Now this is sped up, of course. This takes time for this to happen. But we're going to move off of the surface of the sun and stop the animation right here. But you can use this later on to show the mechanics of what happens in the sky during a total eclipse. Now, the Great American Eclipse. This is the first time since 1918 that the path of totality has crossed the USA's Pacific and Atlantic coasts. So this is the first time in nearly 100 years this has happened. And it's the first time since 1776 that it's been visible from the U.S. only. So this is truly an American eclipse. Therefore, it got its name, the Great American Eclipse. Look down in the lower right-hand corner, and you'll see the path of totality across the United States. It comes from the Pacific, heading from the west to the east. It comes on the mainland at Salem, Oregon, and it is slowing down. Its path of the shadow is slowing down at this point. I'll explain that in a minute. And it reaches its slowest when it hits the Midwest, down around the St. Louis to Nashville area. It starts to speed up again across the face of the United States. It exits by Charleston, South Carolina, into the Atlantic, and then leaves the Earth altogether. The longest duration is where that arrow is, right in the central Kentucky area, 2 minutes and 42 seconds of totality, and it will be dark down there, and you'll be able to see the stars. It'll be an amazing event. Now, from Indiana, and specifically from Indianapolis area, we're going to have a 91% totality because we're just a bit above that line of totality as we talked about. We're going to be above that, and so we're going to be peeking over the top of the moon, and we're going to see a bit of the sun. And so we're going to have a 91% blackout here in the state of Indiana, and it's going to happen, look down at the bottom, August the 21st, 2017, at 2:25 p.m. local time. And I believe all of you are Eastern time. If not, then take that into account. But what we're going to do is animate this for you, and we're going to pull the moon off and start it at the very edge of the sun. When the apparent edge of the moon touches the apparent edge of the sun, that's when the eclipse cycle begins. And it's going to move across the face of the sun and exit off to the left, and we're going to follow this whole thing. Now watch this. This happens at the time you see in the bottom down there, which is 12:50 p.m. Eastern time, just right, almost 1 o'clock in the afternoon. It's going to start, and believe me, every kid in school is going to be out in the schoolyard about that time watching this eclipse happen, and a lot of people are going to know about this because the media hype is going to get more and more intense as we get closer. We're going to start that animation right now. The moon is moving across the sun. Actually, the sun's moving behind the moon. Right now is our maximum at 2:25 p.m. And right now is the end of the eclipse cycle at 3:48 p.m. The entire thing takes 2 hours and 50 minutes. That entire motion that we just showed you. So it's going to be a long event, happens in the afternoon of August the 21st. Now, the best way to view eclipses are these paper eclipse glasses. Let me tell you some stories about this. If you look in the upper right-hand corner, you see that it says actual view. I took that picture with a cell phone camera, believe it or not, and enlarged it through one of these $1 eclipse glasses. That's exactly what it looks like. It's a beautiful image. I then brought a dark circle in to kind of show what the eclipse would look like. But this is certainly the best way to view the eclipse. We would warn everyone that looking at the sun at any time, unaided, will cause permanent damage to the retina of the eye. And we've done lots and lots of seminars all over libraries and civic organizations and schools all over central Indiana. Have many, many more planned up through the eclipse. And we always have this same warning: do not look at the sun. The very best way to do it is with eclipse glasses. Don't just put on 15 pairs of sunglasses, because that doesn't work, because the ultraviolet is just as dangerous, and they may not do a good job of filtering out ultraviolet, but these eclipse glasses do. We have libraries, by the way, here in central Indiana that have ordered 1,000 of these. I would highly recommend that if it's in your budget. Go to Amazon and just type in eclipse glasses, and they have a variety of them. They have plastic ones that look like normal sunglasses. Don't get those, they're too expensive. These paper ones are like 3D glasses, if you're familiar with those. And you can get 1,000 of those for somewhere around $600. It's about 60 cents a piece when you buy them in those quantities. Every time we give a lecture, whether it be a Rotary Club or the Kiwanis or a school or a library, we always recommend that they purchase a large volume of those, because the kids and the general public are going to be out looking at this anyway. They may as well be looking at it safely, and it's great PR and a great service to the community if you provide those. And so I would highly recommend that you get some of those soon, because as we get closer to the time of the eclipse, they're going to be very difficult to find in stock anywhere. And so, again, do not use regular sunglasses, and when you talk with your general public about this, make that recommendation, and if you have the budget to purchase something like this, just give them a pair to keep. It's a great public service. Now, Here's the Great American Eclipse in motion. These are animations that we provided. They're a lot of fun. I'm going to talk through this. Normally during our seminars we have music behind this because we love music, but I'm going to talk through this. Take a look at this. We're going to watch this happen from the perspective of being behind the moon. Here comes that shadow. It's entering the west coast of the United States right now. That dark spot is the path of totality. This is all sped up, of course. We're now heading to the midsection of the United States. This is all the math is correct on this. This is exactly how it's happening. Now we're going through Tennessee and Kentucky, now into South Carolina, and we're going to exit off of the coast of South Carolina. Now that shadow is speeding up because it is being projected onto a sphere of a spherical object, which is the Earth. And so its apparent motion will speed up. That's why the orbital mechanics are as they are. Now, we put this animation together, standing in a farmer's field in Hopkinsville, Kentucky, on August the 21st, 2017, sunrise. This is the period, this is the area of longest totality. Here the sun's coming up, it's sunrise. About noon, a little after 12 o'clock noon, we're going to insert an image into a little window into the upper left-hand corner of this and give you a close-up of totality. And the reason I wanted to do this is to make a point. This is what happens down in the path of totality. For some of you, that's not very far away. You'll have patrons traveling down there. Here's this insert right here. Now, this is 24-hour time. This is 11:45, and as you can see, we've sped the time up. Here comes the moon. And again, this is Hopkinsville, Kentucky, standing in a farmer's field. We're going to have totality here in just a few seconds. And when we do, this is what happens. The corona provides as much light as a full moon, and it will go completely dark. The birds will stop chirping. The stars will come out. You'll be able to see the planets as though you were standing out under a full moon at 3 o'clock in the morning, but it is 2:30 in the afternoon. Back in the old days, they thought it was the end of the earth, and people fled screaming and crying. Now, of course, they fled to the event because we all understand what's going on. Now we, of course, are advancing this computer program and show you the end of the eclipse cycle right there. Spectacular event, and this is what happens at totality. Now, we'll wrap this program up, and we'll start taking some questions if you have those. This, again, is a close-up of that path of totality. If you'll look up in the upper left-hand corner when it enters the United States in the Oregon area, look at that number just below. That is the length of totality. You see it at 2 minutes? And then to the right of that is 2 minutes and 10 seconds, then 2 minutes and 20 seconds, then 2 minutes and 30 seconds. This is because the shadow is slowing down. And that's because that projected image of the shadow of the moon is rising up a spherical object, which is the Earth. And its apparent motion is faster because it's rising up this arc, right? As it gets to the Midwest, it's 2 minutes and 40 seconds. That's because that's where it's directly perpendicular to the path of the sun. And the path is its slowest movement across the land. As it continues to the east and starts to drop off the sphere again, off South Carolina, and start moving out off the Atlantic, it's now speeding up because it's dropping off that angle of the sphere of the planet Earth as you saw in that previous animation. Now, take a look at those lines above and below this path of totality. You see that we've put down direction of travel. Direction of travel is west to the east, always. Look at those lines above it, 90%, 80%, 70%. Well, if you look at where you are in the state of Indiana, and you'll see that 90% is about the Kokomo, Indiana area, maybe a little north of Kokomo. That's because we're peaking over the top of the moon. And the further north we go, the more we're peaking over the top. And so as we get up into the upper part of Lake Michigan, 80% of the sun is being obscured, and further north, only 70%, only 60%, and the same as we travel south. And as you would imagine, when you're on that orange band in the center, that's when you're in direct line with the sun and the moon and the earth, and that's where totality occurs. That's partial eclipses. That's how they occur because of your position on planet Earth. Now, this is going to be fun. We're going to fly along with the moon's shadow from the edge of space. So just imagine, everybody gets suited up. We're going to get inside of a spacecraft, at 100 kilometers above the Earth's surface. That's where space begins, 62 miles. We're going to be right behind the shadow of the moon, following it across the United States. We're going to start in Missouri someplace, and we're going to be at 100 kilometers in altitude, flying at over 1,500 miles an hour, right behind the shadow as it flies across a Google map. I hope you enjoy this. Here we go. As you can see in the upper left, we're in Nebraska right now. Take a look at the numbers on the top. At the very far right-hand side, the width of the shadow path is now 70.2 miles. If you look just to the left of that, the speed of the moon's shadow is 1,480 miles an hour and slowing down. Look over to the far left. We're in Missouri, upper left-hand corner. We're now flying into Illinois. We're right behind the shadow. That's exactly what the shadow would look like if we were in a spacecraft following it. And the irregularities are the surface of the moon and the mountains of the moon being projected onto the Earth's surface. Now we're in Illinois and we're flying into Kentucky, and you can see Hopkinsville, Kentucky coming up. We slowed down to 1,447 miles an hour. The shadow is 71.2 miles in diameter, and we stopped at Hopkinsville because it's the best place in the nation to view this great American eclipse. If any of your patrons ask you the best place to go, it's Hopkinsville, Kentucky. The longest duration of totality is 2 minutes and 40 seconds. Hopkinsville, Kentucky has a population of 32,000. On August the 21st, they expect over 1 million. And we had someone during one of our latest presentations come up to us, said they tried to get a room in the Hopkinsville area. They're $900 a night. And so it's Woodstock all over again in Hopkinsville, Kentucky. If anyone has a chance to go, it's going to be great fun. We're actually taking a bus tour down there. I think right now we have 3 buses packed, these big travel buses, for a daytime trip down there. It's going to be extra fun. So just wanted you to see kind of where this totality is taking place. This will be the most viewed astronomical event of this century. Don't miss out. The media frenzy will continue to gain momentum as we get closer to that date. And I'm sure that your patrons will have more and more questions about maybe some of the programs the library will be providing and questions on the safest way to view for their children and themselves to view this eclipse, etc. Now, here is a screenshot of NASA's website, www.eclipse2017.nasa.gov. I'd highly recommend that you go there. I put a screenshot in down there, eclipse2017.nasa.gov. Look at the top of that web page. Over on the right-hand side, it says Resources. If you go to Resources and click on that, various downloadable and printable PDF documents will show up. I've just shown some of them here. Information about the eclipse. These are all full-color, high-definition PDFs these are all public domain. You can print those in color if you wish and make those available for your patrons. The center one, I believe, is very important, how to view the 2017 solar eclipse safely. And it talks about those glasses. I'd make those available if you want to have documents available for the public. Lower right-hand corner is an eclipse activity guide. And this is a multiple-page download that you can staple together. It depends on what you want to do. NASA provides a lot of public domain materials, quite a few, along with some of the animations you saw here will be available there as well. I feel there's a lot of websites out there about the eclipse. I feel that several things. This is the safest and the most accurate you will find on the web, and everything here is public domain. And so, it's the great American eclipse. We'll all be standing in the shadow of the moon. I've had a lot of fun doing this. Thank you so much. We'll take any of your questions now.
Thank you so much, Greg. So I do have a few questions that I've sort of been tracking throughout the presentation today. So the first thing I just wanted to mention is the fact that there's an equal size in the distance ratio for the sun and the moon. I find that to be extremely fascinating. I think that's so interesting. So that's why they appear to be the same size.
That's right, simply because of that equal ratio.
Yeah, that's really interesting. So we had this question come in. If the sun is moving, is the Earth moving at the same rate of speed, or is the sun moving closer or farther away from Earth? Does that make sense to you?
It does.
Okay.
Well, that's a good question. The sun is of course one of the billions of stars in the Milky Way, and most of these billions of stars, we are learning, have their own solar systems, have their own planetary systems. We are just one of billions, probably, and the Earth is dedicated to the gravitational pull of the sun. And so the Earth has this elliptical orbit around the sun. The sun itself is traveling 490,000 miles around the core of the Milky Way galaxy. It takes tens of thousands of years to make one lap around the galaxy. But that's not relative to the Earth's position at all. We are dedicated to our sun and its gravitational field. And so as we orbit around the sun, which in turn is orbiting around the galaxy, which in turn is orbiting around a large cluster of galaxies, which in turn is orbiting around a larger cluster of galaxies, everything is in orbit. So if you can imagine, this whole relationship today is about the sun, the Earth orbiting around the sun, and the moon orbiting around the Earth, and how those relate to each other as far as our perspective standing on the surface of the planet.
It's really interesting. So I feel like when I was young, there was maybe it was a partial eclipse, I don't remember, but our teacher had us make a pinhole in a piece of paper. Can you talk about that method for maybe there are some libraries that just can't get their hands on the eclipse sunglasses? Can you talk about that pinhole cardboard
Yeah,
method?
I think libraries should have access to a lot of great boxes.
Yeah,
that your books
sure
come
we
in.
do, yes. So
Just
you need a box.
You need a box. Just take a box. This would be a simple, it's called a pinhole camera. Just take one of your book boxes, and we get books all the time from NASA in cases, so we know what they look like.
Sure.
Cut the flaps off, right? So it's just a box with one side missing. And then if the box is longer than it is wide, go to one of the longest sides and take a pencil and push a pencil right through the center to make this hole that's about 1/4 inch in diameter. On the inside of the box, on the opposite side, tape a piece of white paper. And then if you go outside and you hold the box above your head with the open side facing you, like you put that box over your head, and you raise the box up just above your head and you point the hole towards the sun, you will be able to see the projected sun's image on that white piece of paper on the back of the box.
Okay.
When the eclipse starts to happen, you'll be able to see, just like a projector, you'll be able to see this black sphere coming onto the sun until it completely covers the sun. It's called a pinhole camera.
So, but you're not actually looking at the sun.
You're not.
Okay.
You're actually looking the opposite direction from the sun.
Got it.
Because, right, you're looking at that white piece of paper and your back is toward the sun, and the hole is on the other side of the box pointing towards the sun.
That's great. So what I will do for those of us that are watching the webinar is I will find some Pinterest resources for that camera, and I will be sure to share those out as well. Another question that I have, this is sort of a personal question. So there's a child in my life who is terrified of space, terrified. And every time she thinks about planets, the moon, anything outside of the Earth, she understands it all, but she gets very terrified and she just cries, and it's just a bad scene. Do you have any thoughts as to what might help her? Because I know that when she goes to school and they talk about this, she's going to freak out, you know?
Well, I think that's just, from a child's perspective, it's fear.
Yeah.
And there's something fearful that maybe she equates space with aliens.
Possibly.
And that's pretty scary stuff.
Yeah.
And so I think that just understanding that space is a wondrous thing, and developing an interest in our solar system and the awesome planet of Saturn or the awesome planets of Jupiter, and getting a book on the solar system and just going through this and explaining how interesting that is. How old is she?
She's 10.
She's 10.
Yeah.
Well, put her in front of a telescope and have her look at Saturn as an example through the telescope. That ends all fear, I think. That is so fascinating. Yeah. And it's just a matter of education. My guess would be she is equating space with an alien invasion. And that'd scare anybody.
Yeah, that's true. We have a couple other questions. What happens if it's a cloudy day? Will it still look like night? I mean, like...
It'll even look nighter.
It'll look nighter. It'll look darker.
It'll be, of course, when clouds come over, it darkens the thing up anyway. And so here in central Indiana, it's going to be a 91% coverage, which means literally that it'll be 91% less bright. And so you put cloud cover in with that, and now it's going to go dark. And you will miss the eclipse. And if you really want to see it, maybe the thing to do would be, for those that are willing to kind of travel around, take a look on your web app for weather and see at that time and where the skies might be more clear. But
And I've heard of some libraries doing a viewing party where they will actually, stand outside and watch the actual eclipse, or if they're outside of the range so that they're not seeing, 100% or whatever. I've heard that there are places where they can watch it online.
yes.
Is that also that same website that you gave?
Yes,
Okay.
they'll be streaming it live.
Okay.
NASA estimates that over 1 billion people worldwide will watch the live streaming, and over 50 million people will be outside looking up, standing under the moon's shadow. This is a big deal.
That's really cool.
Oh, it's going to be really cool. And for some of the libraries that want to have events like that, some of the easiest and simple things to do, I believe, is if you don't have the budget for glasses, is get in touch with some of the schools and have some of the grade schoolers or the high schoolers become volunteers for the library. Save back a bunch of boxes, cut off the flaps on the boxes, and create as many pinhole projectors as you possibly can that you can pass out that day, and or donate them to schools. It's a wonderful way to use boxes before they hit the trash.
Absolutely. We have another question. Is the eclipse going to cause a drop in temperature for that time? And how is it just going to be during those 2 minutes, or is it a longer time where the temperature will be dropped?
Well, the sun puts out energy, and at full energy, the sun puts out 1 kilowatt per square meter. I mean, that's kind of what hits the surface of the Earth. As you close off some of that sun, or the clouds come over, that energy level goes down, and the temperature goes down. So, yeah, at the very beginning of the eclipse, the temperature is going to start to drop, and at full totality, or even 91%, it's going to be cooler. This is really, to stand outside and experience this is a very visual experience.
Yeah.
I mean, it's a very emotional thing. Honestly, back in the old days, people thought this was the end of the world. They thought it was the end. Everything changes. The wildlife change. The crickets come out and start chirping. The birds quit chirping. The stars come out. It's like the sun just went away, and everything changes. It's really a remarkable event.
And if you just imagine, not knowing the science behind it, it would be terrifying.
Oh, it'd be terrifying. Yeah. And I would imagine, go on YouTube sometime. Well, maybe not, but there are people that are still saying that this is going to be the end. Or so there's people that hopefully they don't really believe that. But education, we've learned a lot over the past century or two.
So a couple other questions. Someone's wondering, can we use bits of this webinar to show people prior to their viewing party? And I would think the answer to that would be yes.
Yes,
right?
please do.
Absolutely. And another question, is it safe for people with retinal tears or other vision problems to view the solar eclipse using the viewing glasses?
Yes.
You think so? Okay, yes.
Absolutely.
Okay, great. Sherry says that Amazon has the glasses, 20 glasses for about $16. She's showing various prices. Thanks for looking that up, Sherry.
Well, tell Sherry that, as you get higher quantities, the price goes down. But, you can typically find them. And believe me, as we get closer, prices will go up. That's just how things work. Mm-hmm. But, you can typically find them for $1 a piece. And,
right.
And, if you find them for $1.50, that's one thing. But you get smaller quantities like 10 or 20, you're going to pay a premium price.
Are you familiar at all with the resource StarNet libraries? And
I am.
Okay, and I think that they did a big glasses giveaway.
Oh, good.
And several of the libraries in Indiana received glasses from that. I think that that's over, so I don't think that you can still get those glasses any longer. If somebody on the webinar knows, you can be sure to let us know. But I just wanted to mention starnetlibraries.org, and I believe that they're associated with NASA.
I'm sure they are, because they're associated with libraries nationwide.
Right. Yeah.
Right. That's their connection.
And I also wanted to mention some programs that other libraries are doing. I know that Pendleton and Newcastle are both giving away glasses. Carmel Clay has lots of events planned. Bedford Public Library is also having programs and a viewing party. So there's lots of libraries that have things going on. We do have multiple attendees typing, so I'm going to let people kind of get their questions in.
I would recommend that if you're outside of the Indianapolis area, look up on the web and contact your local astronomy club.
Oh, that's a great idea.
They're a great resource for for an Eclipse Day event.
Yeah. Shannon says, if you're having a viewing party, Spotify has put together an Eclipse playlist. So that's exciting. So you talked about how music can sometimes be fun in the background.
Here Comes the Sun by the
Yeah,
Beatles. That's
yeah.
perfect.
And then Catherine says that her library did get glasses from StarNet. They're real excited to have a town-wide viewing party. That's
my
really
gosh.
great.
That's awesome.
That's great. Joan is wondering, is there a list of the programs that people are doing? And Joan, I'm assuming that you mean the library programs. I have not been compiling one other than those few that I just mentioned. If you'd like, you could certainly send a note out on one of the listservs, and you could compile it for everybody if you want. That would be wonderful. Kirkland Library was the library that received glasses, but they're not giving them away anymore. Okay, thank you, Heidi, for letting us know. Okay, Joan, clarifying that you're interested in library programs, and I would just suggest that someone write out to the listserv and ask and see if we can get a list going. In preparation for this webinar, I sent a few feelers out, and I know there's a few things. So, I did want to mention, let's see here. I'm going to see if I can, where is it? Oh, never mind. Never mind. I was trying to find something, but I think it's on my other computer. So I am going to go ahead and put in, this is a link to our survey for this webinar. I see a few of you are still typing. Feel free to go ahead and take that survey about this webinar. We always take a look at those really carefully, so please take this survey so that we can improve our webinars in the future. We do still have multiple attendees typing. While you guys are typing, I'm going to go ahead and work on getting your LEU ready to go. I do have to upload it, so just hang on a second. Will there be a log of this presentation to view? Yes, the presentation is recorded, and we will be sure to share that out with everybody. Sorry, now I'm trying to do two things at once. It's a great idea to reach out to your homeschool community as well. That's a great idea. Okay, so your LEU document is there. We're going to keep the recording going a little bit so we can capture a few more of our conversations here. All you guys have to do is click on that document, and then you'll be able to download it onto your computer. That way you have a document for your LEUs. Couple other questions, comments. Their library got glasses from StarNet. They're having a viewing party as well. They have a large homeschool population. They're offering a homeschool program the day before the Eclipse group viewing. I think that's a great idea. I just wanted to mention that you don't have to limit your programming to the day of. You know, you could do a program ahead of time to kind of get your community ready for the Eclipse. Maybe you could do something for your teachers or in partnership with your teachers, of course. Awesome. Okay, well, it looks like what most of you guys are saying now, you're sort of reporting out the kinds of things that you're doing. We're really interested in hearing that. Link, we have someone that says that they didn't know very much about Link Observatory. Do you want to take a quick minute to tell us a little bit more about Link and the kinds of things that you guys do?
Sure.
Great.
Link Observatory was built in 1939 by Dr. Getty Link, who was a thyroid surgeon in Indianapolis, and obviously an amateur astronomer and a wealthy individual. And at the time it was built, it was the 8th largest in the United States, and of the only one of the top 10 largest telescopes in the U.S. that was privately owned. In 1948, he donated the observatory to Indiana University. The observatory is on the southwest side of Indianapolis in Morgan County between Mooresville and Martinsville on State Road 67. It's a magnificent, beautiful place. IU used that for science research until 1988, when light pollution from the growing Mooresville, Martinsville, Indianapolis to the north had made deep sky astrophysics and astronomy challenging at the academic level. And so Indiana University built other observatories in darker skies and owned one, I believe, with Yale University down in Tucson, Arizona at Kitt Peak. And so in '88, it was decommissioned, so to speak. It's still a beautiful place. It was used on and off by the Indiana Astronomical Society, who are the caretakers of the facility. In 2012, I had a meeting with the then chair of astronomy at IU, and had laid out a plan that we could provide educational programming and public programs at the observatory and bring it back to the public again, because the gates had literally been locked for all those years. And so that's what we did, and we founded in 2012 the Link Observatory Space Science Institute, and since then have started a wide variety of public programs. Lectures, we call them Link Live. They're much like a TED Talks type of a program with stage lighting and music and a variety of speakers, and very entertaining. We pack the house wherever we go. We're at a variety of libraries all throughout central Indiana. When we're at Morrisville Public Library, we then have shuttle services that take people down to the observatory, and we'll have we've had 325
Wow.
people show up at the Morrisville Library. They seat 145, so figure that one out.
Yeah.
And we had shuttle services then take all night long to the observatory, always free of charge. And so people can, at the observatory, be able to look at the wonders of the universe through this magnificent telescope. We're bringing it back up to science standards. We've now created STEM educational programs that are digitally delivered to classrooms throughout central Indiana and expanding. Some of those field trip programs to the observatory utilize solar telescopes or hydrogen alpha telescopes on site so that we can do daytime astronomy at the observatory. We have over 10,000 kids out there for daytime astronomy in 2016, and over 17,000 people attend our public events. So it's really grown just over the last year and a half.
Fantastic.
And we're in a partnership with IU. We just had a big meeting with them yesterday about expanding even further. And so we want to make this Indiana's Space Center. We love public library work because that's kind of a doorway to that part of the community. If you are interested in Link Live events in your program room, there is a section on our website at linkobservatory.org where you can fill out a questionnaire. We'll make contact and tell you what that's all about.
Great. Well, thank you, Greg, so much, and thanks for everyone who came to the webinar today. I hope that you guys have wonderful programs leading up to the eclipse for your library, and we look forward to doing more webinars like this with Link in the future. So thank you so much.
Thanks. It was great fun.
Thanks, everybody.